Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your technical questions answered, and contribute to the community forum. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our construction, tech, or weekly Global Passive House Showcase webinars. In the meantime, here's this week's Passive House podcast. Welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Auckland in New Zealand.
And I'm Zach Semke, coming to you from Seattle, Washington.
How you doing, Zach?
I'm good. I'm going to focus on the positive. We've had kind of a rough week in the U.S., but we don't need to talk about that right now. Gun control is important. But I am looking forward to this weekend. It's Memorial Day weekend, and my family and I are going to go over to the Olympic Peninsula, which is where I grew up, and we're going to get to adventure in the mountains and maybe see some whistling marmots and have a good time. So looking forward to that.
Nice. Yeah, well, it's definitely cooling down. We've had a eventful time this part of the world. Had the Australian election last week, which I think, could be a positive for the climate. There's a lot of change towards people who think that doing something about climate change is a good idea. So that's good to see. And we've also had a budget announcement and quite a lot of policy announcements around climate change here in New Zealand. A little bit of a slight backward step in terms of regulations around the building code, but we're continuing to push for people to build better and encouraging people to, as always, just because the code hasn't changed the minimum requirements doesn't mean that you're not allowed to build above those requirements. So we're really pushing the fact that there's a very clear indication of where the code is going to go. So if you are designing or building now and you're only building to the current standards, you're basically conscripting your future house to be obsolete as soon as it's finished, because it will be among other houses and other buildings of a higher insulation standard. So why would you design a build to the minimum possible that you're allowed to today? So got a bit of work to do there, but hopefully things are going in the right direction.
Yeah.
But we've got some leading projects to talk about. Oh, I also another thing that's happened this part of the world is we'll have to get back a guest to talk about the community centre in Australia. We had an interview with the architects, I think earlier this year. One of the first community centres to be Passive House certified, and that's just opened in Australia this I think it was last week.
Oh, exciting!
So that's pretty exciting. I've seen a few articles about that, and we should definitely loop back and find out how that's performing.
Yeah, absolutely. That's a really cool project. So it'll be fun to see it in action.
And this week's feature interview is also another project which will be familiar with some people, because our guest has been on the Passive House Live, and we've also got a few articles, but I really wanted to just reach out and have a bit more of an in-depth conversation with Jamie Harte about his amazing couple of projects, actually, one in particular, but dive into a little bit of, or he gives us a bit of a hint about other things that he's been working on as well in their practice. But before we get into that, let's thank a few people.
Yes, absolutely. So everything we do at Passive House Accelerator, including the Passive House podcast, comes thanks to generous support from our sponsors. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingwe Architects, Glavel foam glass gravel, Minutair all-in-one HVAC and dehumidification units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. Thanks also to our champion sponsors, Icon Windows and Doors and Proseco. And thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
Awesome. All right. Well, as I said, Jamie Harte will be familiar with some of our listeners. He's an associate architect at Public. There's Public Architecture and Communication, and he joins he was featured on Passive House Live back in March this year to talk about the University of British Columbia Skeena Student Residence project, which is Passive House certified. And it's 220 bedrooms in a 6-story building. And there are some photos on an article on the Passive House Accelerator website. And you can also check out the video from that live session. But having seen a couple of other posts about the project and seen that it was making some bit of a splash for good reason, I wanted to reach out to Jamie and ask him why he got into architecture in the first place and how he got into Passive House. So it was a pleasure to sit down, and I hope you enjoy this conversation. Well, Jamie, thank you for joining us on the Passive House podcast after your great presentation earlier this year, back in March, on Passive House Live to talk about the dormitory project in Vancouver. So it's great to have you on the podcast.
Yeah, thanks very much. Thanks for having me.
We'll pick up a little bit about the Kelowna project, but before we do, let's talk a bit about your journey to be working on Passive House projects in Vancouver, because you're not originally from that part of the world.
No, originally I'm from Ireland, and then I studied architecture in Scotland, in Edinburgh, for 6 years or so. That was a great time, and then I moved to Canada about sort of 11 years ago to British Columbia. So not from here, but my work experience is kind of almost all in and around kind of Vancouver, lower mainland of British Columbia.
What took you to Canada?
Just, I suppose, the opportunity to sort of have a good time and spend a lot of time outdoors, lots of snowboarding, all that kind of thing.
Nice.
So I lived in Whistler for a few years when I came over.
Awesome.
And then I also worked for an architecture firm up there, which was kind of a rarity to have an office job in a kind of a ski resort town. So a couple of things kind of went my way, but yeah, that was the motivation for. Wasn't planning on maybe initially spending so much time here, but you know how it is that you kind of go year by year and keep having a good time, and then end up kind of getting settled. So
yeah, sounds pretty ideal. What got you into architecture in the first place?
I think I knew sort of a couple of years before leaving high school that I was going to be applying to architecture school. It wasn't so much that I was, a lot of people say, they were always playing with Lego and kind of making things. And I don't think it was necessarily that. I just found it it's a really interesting job that's kind of right in the middle between a whole load of things to do with, cities, space, people's lives, economics, sustainability. It's kind of like it's a really interesting job. It's kind of endlessly challenging. I think it's a way for me to kind of find an outlet for a lot of things I'm interested in, all kind of in one job. And and then once you start doing it, you realize every project is totally different and challenging. So the problem solving aspect of it is really satisfying.
And when did you first come across Passive House?
So I was working for a firm in Whistler, which is about 2 hours north of Vancouver, when I came over first for an architect called Derek Venter, and that was a small firm, just kind of five or six of us in the office, and he had a particular interest in it, and he actually sort of decided to put the whole office through Passive House training with Passive House Canada. I think I knew a little bit about Passive House in terms of just the theory behind, fabric first approach and being less reliant on mechanical systems, but I didn't really know anything about it as a system and a sort of, a certification, things like that. So it was really, interest cultivated by my employer Derek, and he sort of stepped forward and saw the future in it and put our office through all that training. And Passive House Canada has a great kind of series of foundational courses to get people going with it.
That's a great commitment from a practice. So no formal training in Edinburgh when you were studying architecture, but I guess, were you aware of Passive House back in Ireland?
I don't know. It's always one of those things that I think when you hear about it first, it's always amazing to hear about that it's actually been around for 30 years.
Yeah.
So I think it was in the air, but I don't think I knew about it as, something that you could kind of apply to all buildings, that it was, that it was really something more than just kind of general theory around design and construction, that it was really kind of quite a neat system that works together and that it's not prescriptive and everything. So I don't think I knew much about it. I mean, even around here, the first Passive House was built for the Olympics in 2010, which was the Austrian pavilion. So even here, when I have a lot of architecture colleagues from different offices and things that have Passive House certification here, and people talk about it a lot in Vancouver, but it's still only 12 years ago that there was just one project in the whole country. So I think over in this side of the world, it's really kind of exploded in the last 5
I think it
years.
I mean that the shape of the curve would indicate that even though you're right, it's been around for 30 years, but particularly outside of Germany, that was fairly low, fairly no numbers for quite some time, and more recently that the slope of that growth has really ramped up, and I mean that's what we're seeing in this part of the world as well. That more and more people are at least hearing about Passive House. Probably don't quite understand it fully, but at least hearing about it to start with. And then, what's the general understanding now in British Columbia? We talk about British Columbia and the step code quite a lot. In your field, architecture, but also in contracting and builders, what's the general understanding of where Passive House sits compared with the current building code and the future building code as well? Because that's the point of the step code, is that it gives you a roadmap of where things have got to go.
Yeah, so I think obviously knowledge about Passive House is definitely expanding. City of Vancouver deserves a lot of credit for that, for really just recognizing the simplicity and the value of the Passive House, like the Passive House standard as a kind of standalone system, and not just trying to rewrite it into their own kind of language and their own system. And it's a lot of work has been put into the Passive House standard globally, and I think it's good that City of Vancouver just recognizes it as a standard for compliance and not requiring conversion of metrics into their own figures. Like, you can just work with a certified Passive House designer or consultant, get the project certified to Passive House Classic, and they'll kind of answer all the questions they have about new construction for any scale of building really in Vancouver. So they deserve a lot of credit. And then I think more broadly across the province, the fact that the step code kind of speaks the same language as Passive House. So all the steps, it's measuring, Teddy in kilowatt hours per square meter per year, which is kind of essentially the Passive House heating demand. And then it's got the EUI, which is kind of essentially PER as a second target. And then it's not quite as exacting when it comes to air tightness, but it's speaking the same language as Passive House. It's giving a roadmap to get to almost Passive House for all new construction in the next sort of 8 to 10 years. So I think it's been signaled that the industry is going to get there. Like that's the target. There or thereabouts, let's say, is Passive House, and then there are incremental steps that allow different municipalities to go at different speeds between that. And I think municipalities closer to Vancouver are tending to maybe move a little bit faster than ones that are in a little bit more rural areas, but I think that's natural.
I think you mentioned the term Teddy, which some people will be familiar with. I quite like it as a term. So that's thermal energy demand intensity. Is that correct?
Yeah. So that's what's referenced in the building code here. But then you can also, if you're doing a Passive House project, it sort of maps onto that anyway, even if the terminology is slightly different. So it's good that they haven't sort of pulled the rug out from under the Passive House standard by making people do, 2 certifications, or making people convert, if you're working on a Passive House project, kind of convert your calculations to something else. So I think it's been well recognized in the standards here as a kind of exemplary approach.
Which is it's such a great metric because it's measuring what's important. We have some schedule methods where it specifies the amount of insulation you can get away with or are required. But there's so much dependent on where that insulation is and how well it's installed on how effective it is. So to measure the actual output or the performance is a far better way of doing it, and then leaving it up to the designer and the construction crew to figure out how to achieve that.
Yeah, I mean, I think the flexibility in the system is something that I really like. I think there's 2 parts of Passive House standard that are really interesting to me. One is something that's really rigorous, and it kind of it's one of the few sort of broad developments in construction that really meets the scale of the challenge that we're facing. It's not sort of saying, well, this is an ideal scenario, this is where we are, and we'll split the difference and go somewhere halfway. It's rigorous enough to say this is the standard that you should be building new construction to, and this is a standard that meets the kind of critical condition that we're in with regard to climate change. And then secondly, I like that it's not prescriptive. So I think it's interesting to look at jurisdictions where they have really broadly applied Passive House as a kind of a building regulation, like in Brussels, and just see the diversity of projects that can be built, when you have a whole industry tooled up around a fairly big city to deliver projects that the design team and construction team can produce very different solutions to the same standard when the knowledge of that standard gets a little bit more mature. So I think you see in the early days of Passive House, you see in British Columbia, you see a lot of houses that look very similar, often because they're literally learning one from another because the community is so tight. And then I think that the diversity increases over time as everybody gets a little bit more familiar with it.
Absolutely.
So that's something that I'm really looking forward to seeing.
Yeah, well, I know I'm very lucky to go and visit Bahnhof in Heidelberg, and similar thing there where the requirement for that whole development is Passive House, but the buildings all look completely different designers, different users. And we also talk about that quite a lot in what we're starting to see in Australia and New Zealand, and some of the architects thinking about designing for warmer climates and really producing things that you wouldn't be able to pick from some other architecturally designed quite fancy home. They definitely don't shout out the fact that they're a Passive House.
the sort of more the older style, what you might think of a square box with small windows.
Yeah, I mean, it varies so much even with building type. So, there's a project not far from where I'm at the moment by HCMA, Vancouver firm, which is Clayton Community Centre, which is a passive house community centre in Surrey, which is the city next to Vancouver. And that, considering the climate zone that we're in, looks like a relatively slim wall. But it's got huge internal gains because it's got a kind of a fitness center in there. So they're dealing with kind of unique, even within the same climate zone, they can, you can have totally different challenges to solve depending on the occupancy and the functions within the building.
Yeah. So now, Kelowna, the project that you presented on, 220 bedrooms and 110 bathrooms. It's a lot of services going in there. You got a couple of lounge rooms, common room. There's no kitchen in that building, is there? No.
There's like a residential style kitchen in the floor lounge at the end of each unit.
Right,
so
but not a big commercial.
It's kind of a stack of 5 lounges with just like a residential kitchen, like a 1-bedroom unit size kitchen just in the corner of the room. So nothing major there.
Some pretty impressive metrics that you presented on. Got it down to 0.08 air changes, which is pretty amazing. 8 inches of semi-rigid rock wall on the outside. I haven't done the conversion to that to metric, but people can figure it out. It's quite a lot. And some pretty impressive. Was it triple glazed, the windows?
Yep.
So definitely head over and check out. It's a really succinct, short-ish video. Great presentation that you did to the Passive House Accelerator. What is the climate there? I mean, you're in a tough place because it gets really cold, but it also gets quite warm, doesn't it?
Yeah. So actually, 2021 was a real illustration of that. I think there was it a 60-degree temperature swing that they saw? So I think in North America, there's parts of Montana that have like the biggest temperature swing from winter to summer. And if you kind of head north of there and a little bit west, that's kind of where, like, it's interior British Columbia. It's about 5 hours in from the coast as a drive. So they get really hot summers, a lot hotter than on the coast in Vancouver. And then similarly, they get colder winters. So it's a big swing, and it's definitely a challenge to design for that, like summer comfort and winter as well. So,
was PHPP up for that challenge?
Yeah, we had. I think I started on the project in 2018, so it probably started a little bit earlier that year, and the PER target of 60 kilowatt hours per square meter per year, I think, it's kind of almost impossible to hit that for a building that's as densely occupied as that is, in terms of like domestic hot water use and plug loads. You've got a lot of students that are plugging in the quite inefficient sort of bar fridges that go in underneath desks and things. So realistically, when you enter in all the energy use for 220 students in quite a small footprint, because they're all individual kind of student bedrooms, so it's really densely occupied. So we kind of had to ask for an exemption or a relaxation on that, which has become a pretty common thing. And it took a very long time to find out what our revised target was. So that was the kind of one challenge with meeting PHPP, was not so much on heating demand, cooling demand, or heating load or cooling load. It was really about primary energy and trying to come to a common agreement between the design team, certifier, and PHI about what was reasonable.
Are some of those appliances supplied by the students?
Yeah, and that's the problem. That's like, you kind of have to be conservative with entering them. I think if the operator was going to provide, they don't provide fridges in rooms, but then they know that students bring them in because they have other residences on campus. So you have to be quite honest about taking kind of standard student lifestyle and making that your assumption for this. So in other projects, maybe the operator might be prepared to purchase equipment which is all kind of Energy Star rated,
Yeah.
and just deal with that in the capital cost. But the standard kind of approach here is that people come with equipment of varying efficiency, so you have to kind of be conservative when you're trying to capture that in the energy model.
Yeah. And it was the first project, first passive house project of your practice at Public.
Yep. So it's first one, and first for the client as well, first for the contractor.
Yeah.
So yeah, it's definitely a first.
How did that feel? Did that make you nervous, having all those firsts?
I had worked on, at my previous job with Derek Venture in Whistler, I'd worked on a multifamily passive house project, which is in Squamish, kind of halfway between Whistler and Vancouver, which was smaller in scale. It was kind of townhomes or like row housing. So it was essentially, lots of individual mechanical equipment. It was basically like doing a lot of single family homes together. So I had a little bit of experience with the standard, and I'd gone through the training, but yeah, I think it was huge learning all around. For everyone.
I was interested that you managed to do this, or you designed it with fundamentally conventional construction, the timber framing, the structure, and it wasn't anything out of the ordinary. Other than, they had a bit more space to work with on the campus, and then did a little bit of on-site prefabrication. Was it the fact that you had a dedicated contractor that was able to look after all of the control layers outside of the main building structure? Do you think that was quite an important part of achieving Passive House?
Yeah, I think we had some challenges to do with scheduling, in that we had student housing has a really hard deliverable date of kind of August of a given year, and if you're late, it's kind of unacceptable because the students have to be housed somewhere. So you miss that date, and it's just a huge problem. So when our start date was also kind of a little bit delayed at the start, so we were trying to build it all in, I guess it was 16 to 17 months, which is tight for a big building to do it conventionally.
Yeah.
But to do it as a kind of a first passive house project for most people involved in it was a kind of extra challenge on that. So I think the approach to managing risk was to try and make as many components in the building as conventional as possible, so that you can get the building topped out and framed with as much speed or more than a normal project. And then from there, there's a relatively smaller team of people who've been going through shop drawing review process and really kind of getting their heads around the challenges of kind of airtightness and super insulation and really good window installation. So you try to put risk on a smaller number of people and work really hard with them, and then let people who can just kind of show up and really fly through the building, let them do their thing. So we have a wall assembly that's kind of responds to that. And then I suppose there's also a little challenge if ultimately there's an outside chance that perhaps the client might have at some point rode back on their commitment to Passive House, and just in order to protect the schedule, we had a kind of a wall assembly where you could trim back the exterior installation and it wouldn't have affected any of the framing or the layering of materials inside. So just trying to manage risk is all about how we kind of laid out the form and the sort of basic assemblies of the building.
Yeah, you mentioned that during the video, that the owner, I guess the driver, they were still, what was it? They had to get everything past the board, and there was a risk until quite late that they could decide not to go down the full certified Passive House route.
Yeah, I think it's kind of it was in the project from the beginning that it was going to be certified Passive House, but just knowing, we're living in a time now of crazy cost escalation, but even in 2020, labor shortages, and there's, quite a lot of pressures on the budget in any project. So, it's always there's always a kind of slight nervousness that someone who's approving capital spending on a huge scale across university might see the passive house standard as a kind of a nice to have ultimately if the project really needed some cost efficiency. So
Yeah.
I don't want to overstate and say like we were planning for it, but there was always a small chance that might happen. So it definitely gave us a little bit of confidence that we had a building that could kind of proceed even if we had to go to a slightly lesser energy standard.
Were any cost estimates done? Do you know what if there would have been any significant savings if you had to pare back the thickness of the insulation, for example, or change the scope?
I think there would have been some envelope cost savings. Our mechanical room would have had to get bigger, a mechanical plant, in order to get rid of the passive house system. So you kind of have other areas. It's not just all saving when you try to, if you think about taking passive house standard out of the project, it's not just all a cost saving. There's some kind of extra complexity. There's some efficiency that you get by doing passive house. And the project already had individual kind of thermostat control for heating and cooling for every student. So there's already quite a lot of extensive mechanical equipment, and that means kind of 220 fan coils in there for heating and cooling, and I'm sure those would have been provided regardless of the energy standard. So there's a lot of cost involved in the project that's not really related to passive house, and then there's some savings on space savings for mechanical and simplicity around that you get with it as well.
Yeah, absolutely. Ventilation, how you were building right in the middle of COVID and you had that as a constraint as well as the time pressure to deliver before all the students turn up with their fridges to put their beer in. What challenges has that impacted the ventilation design at all? Thinking about COVID and just all those students living close together?
No, I would say so. We managed to get, I think, virtually all materials were on site by March 2020. So project was kind of like just completed during COVID, which caused certainly some headaches around just resourcing and getting people field reviews on site and everything. So design and the majority of construction kind of preceded the pandemic. With regard to kind of its performance, thinking about COVID, so the first year the building was occupied was kind of on half occupancy. So our plan is kind of 220 rooms with 110 bathrooms means that each pair of student bedrooms shares a bathroom. So during the first year of the building's occupancy, which is September 2020 to May 2021, it was kind of on half occupancy or maybe even less, so people weren't kind of sharing bathrooms and so on. But the building is fitted with a whole load of sensors related to temperature, humidity, CO2 levels, and so on. And there's a big academic study happening by the engineering department there. So we have we have temperature readings about how the building's been performing from a temperature point of view, but we're looking forward to finding out humidity and its effect on spread. Low humidity in the winter is not a good thing for spreading any sort of viruses. So we'd hope to see a good humidity maintained in the wintertime, and then also we'd hope to see good low CO2 levels as well, just as a general indicator of kind of freshness of air and the turnover of air in the building. So hopefully we'll hear some of the academic data on that in the next few months.
Have you seen some of the outputs from the monitoring yet?
Just in terms of temperature, we had a couple of kind of interesting results. So during the heat dome that hit kind of Seattle, Vancouver, and everything in late June last year, by coincidence, the cooling system had to be taken offline for maintenance, I think. So the commissioning agent for the building, he actually pre-cooled the building to 17 degrees Celsius just to see, in advance of, a really intense heat wave coming in. And I think it was 44 degrees outside, 17 degrees inside, cooling not working. And it only really rose by about 2 degrees Celsius per day during that time, even with a, whatever that is, 25 degree temperature delta inside to outside. So there weren't many people in the building at the time, so it had lesser internal heat gains, but even still, the huge solar gain and temperature difference from outside still didn't manage to kind of overheat the building with no cooling on. And also it would have had no natural ventilation happening at that time. So it's just purely about the slow phase shift of temperature through the exterior walls and roof.
So it's
pretty impressive. That was good to hear that it had a certain resilience to it. And then I think it's also maintaining its temperature really nicely from winter to summer in heating and cooling conditions.
How many separate ventilation systems are there?
There's two, either two or three. I know there's three ERVs, one of which just serves the common area on the ground floor, and then there's two others that act in a pair to serve the residential levels up above.
So you weren't required any time to redesign that and try and get individual air supplies to and have completely separate ventilation systems?
No, I don't think so. I mean, the building was kind of all the duct work done and everything, before. I think the centralized system certainly suits this kind of occupancy, not having to go in to any other parts of the building for filter changes and so on. So having everything, served from a central plant suits the operator, and it's an efficient way to do it. And then, I think from a sort of indoor air quality and pandemic point of view, I think we would hope to just see really good turnover of air in the building, maintaining good humidity. Obviously, for outside particulates, it's also filtering the air quite nicely, and we're hoping to get some sort of anecdotal information about how it handles wildfire smoke as well, because that's another thing that's, we get wildfire smoke in Vancouver, but it's more extensive and more common in Kelowna. Just by not being so close to the coast, it tends to linger more. So hopefully we'll get some feedback about how, with the windows closed, cooling on condition in the summertime in poor air quality, how's the air inside? Is there any trace of kind of wildfire smoke making its way through the system?
Yeah. I was interested. You mentioned that there were some things that a student accommodation doesn't require, things like balconies or a lot of car parking, because that's sort of dealt with separately. So in some ways, there are some commonalities, but there are also some other challenges when working on a more market-oriented type building, which you're doing now with an interesting project. Tell us a bit about the Vienna House, and if there's any crossover between what you've done with the student accommodation and that project. Yeah,
so Public's the architecture firm and lead consultant on Vienna House. So it's a different project in a lot of ways. The commonalities are that it's again certified passive house. It's got a focus on kind of long-term thermal comfort, and the differences being it's located in Vancouver, so much closer to the coast. It's multifamily housing, so there's 123 units of social housing in there. It's got a lot of balcony requirements, which I think we've come up with an approach that makes sense kind of thermally and everything. We try to use balconies on aspects where they provide a solar benefit as well as an amenity. But it's a very different project in the sense that the Skeena project is a very tight, regular form. It essentially kind of has just 4 outside corners and 2 little in-cut doorways at either end, and otherwise it's just a kind of extruded rectangle. It's about as simple as it gets, and just totally repeating form, generous site because lots of work around space, whereas a Vienna House project in Vancouver has extremely tight site and irregular shape, hemmed in against an urban railway and surrounded by another busy kind of arterial road into the city. So it's kind of noisy. It's really tight for construction space and laydown space. So it's a totally different project in terms of its kind of pressures, but again, you learn things from one approach to passive house that you can take to the next. And I think there's a lot of coordination skills that you get from working on a passive house project that transfer forward no matter what the challenge is next time. You've got ways of working with your mechanical consultant and energy modeler and certifier and keeping things moving, in an efficient way. Those are in common no matter what project you're working on.
Yeah. And that one, what's the schedule for Vienna House?
It's going to start construction probably in about February next year. So we're just getting the site rezoned at the moment and about to apply for a development permit. And then after that, a building permit kind of at the end of this year. So it's we're still in just moving into working drawings phase now.
You got good solutions for minimizing the thermal bridges for all those balconies?
Yeah, so we've got kind of wall assembly, which we're looking at doing a prefabricated panel. So we've got some kind of solid framing on the outside, which helps to attach, one side of a balcony without having to connect through a lot of exterior insulation to get to solid framing. So we're kind of moving some of the solid framing further out, still getting a really good U value for the overall assembly. And then, no cantilevers so that we don't have any structure passing through our exterior walls.
Right.
So it'll either be a completely independent structure on 2 rows of posts or just on one side and bearing back onto the exterior wall, and then just having solid framing kind of further out in the wall assembly.
So they're basically almost like clip-on balconies.
Yeah, so you can kind of waterproof past them, and air tightness passes by them and everything, just to kind of treat them as clip-on elements.
Yeah. Very good stuff. Well, I look forward to a few videos on the accelerator going through that one, because that looks like a fantastic project. Both of these are great examples of the diversity of passive house and being used for different end uses, different clientele, and lots of people benefiting from warmer, healthier, drier homes and much lower operating costs. Both of these, do you see these, what you've learnt, as repeatable, scalable? Are there any major barriers to doing a lot more of this type of thing for similar projects across Canada, but anywhere really?
Yeah, I think we, in terms of student housing, it's really kind of low-hanging fruit when it comes to passive house. The fact that you've got, generally you don't have a requirement for exterior balconies or many exterior doors. So there's so many repeated kind of window details, and simplified massing is really easy to do. So I would see that, the lessons from the Skeena project are really applicable to any project of that kind of typology, because it's a type of building that lends itself to passive house really well. Doing student housing, it's sort of, the client is generally the same person. It's the same entity that operates the building and pays for the long-term energy use. So there's a big benefit to the client. And then it's just as a typology, as you said, there's no below-grade parking to negotiate. So it's a simple kind of building form. And then Vienna House, very different type of project, but we're doing it in a courtyard form to respond to its noisy site conditions, which is very unusual generally as a typology for sort of multifamily housing, at least in this part of North America, and certainly not common when you start thinking about passive house projects. But I think there are lessons to be learned. We found that as pure kind of construction efficiency, it's actually quite efficient because it's in a loop that you're serving everything from the center. So your circulation is relatively compact. We thought that it was going to be, a lot less efficient than just doing a single central corridor splitting the building. So we've learned from that it actually can be quite efficient to do a courtyard with a looping circulation in the center. And then I think as a typology, courtyard multifamily housing offers a lot of benefits to kind of mediate a little bit between winter and summer pressures, especially like we're kind of, Vancouver has one toe in a kind of a cold climate and another in a warm climate. So it's we're trying to kind of mediate between the two and not solve the winter condition with a super compact form that actually exacerbates summer overheating problems. So it's a little bit more generous in terms of exterior envelope area, still quite compact, but it gives, the ability for cross ventilation for all the units, which is not common in this city. I mean, it's called Vienna House. It's a very common solution in Vienna to have thinner building floor plates, less like a bread loaf in shape and more kind of slim. So I think there's a lot of lessons that can be learned for other projects from Vienna House. Certainly as we start to build more dense housing in kind of noisier city center locations, that ability to create this kind of calm center space for people, I think will become really valuable. Yeah.
Nice. Awesome. Hey, well, thank you again, Jamie, for your time, because I know that you've already presented quite a lot, but I guess that's part of the price for doing interesting projects, is that other people want to hear about them. So
definitely.
Keep up the good work, and we look forward to hearing more about some of those other exciting projects in the future.
Great. Thanks for having me.
And that was Jamie Harte of Public Architecture and Communication, mostly about the Skeena Student Residence project, but also some other really exciting projects that Public have got coming up that Jamie and his team are involved in. You've obviously had a bit to do with Jamie in the past, Zach, from being on live and him being a guest on Passive House Accelerator before. Any made takeouts from that interview?
Well, first of all, it was a fantastic interview. Jamie's presentation was one of my favorite that's been made at the accelerator. And I was just the kind of simplicity and thought and design that went into the UBC Skeena Residence is really inspiring. So it was great to be able to follow up and listen to this interview with him. And also I was not aware of the impact of snowboarding on Passive House practice in Vancouver. I mean, that was pretty cool. Yeah, and going back to that, his experience in Whistler with that firm, I was struck by the ripple effect that architecture firm owners can have on practice. So the fact that the owner of the firm that he was working at decided to train the whole staff up with Passive House and really dedicate the practice to Passive House has made a broader impact. And when I was at NK Architects, I think maybe the second week I was at NK Architects back in 2016, the entire staff was also trained up by Tomas O'Leary from Ireland. And so I often think about all of those designers who have been trained there, who are now at different firms in Seattle, and what kind of impact that hopefully will have. We saw that, directly applying here with Jamie's work. You were talking about all the firsts that were going on with the project, and the fact that Jamie actually was experienced. And so I think I just want to kind of celebrate the investment that these first movers are making in training up the people who are going to make this transition happen.
Yeah, I've in various roles been asked to justify a training expense or a course to go on, and sometimes it's hard to say the immediate payback on that, and often it might not be directly for that firm even.
But right, there's some
it is an investment.
Yeah,
it's an investment in people and an investment in the industry, and we see that ripple effect certainly through formal training and certification of people. But the other big impact of a ripple effect is people working on these projects at any level, whether they're a main contractor, something coming onto site to do some services or mechanical services, and it might be the first time that they've heard about this thing, or they might have heard about it but never worked on a passive house project, and then they're learning on the job about airtightness and it's a different experience from other building sites that they've been on, and that can't help but impact people, particularly if your project goes through a winter and you're working inside after it's closed in and probably actually quite comfortable. You probably don't want to go back to a regular construction site.
Yeah, right.
So it is a very powerful experience having these projects that don't just influence all the people who get to live in a place like this after the fact, but also the people that work on and around it during construction. You mentioned simplicity. I think Jamie is one of those people who's smart enough to make complicated things sound very simple. Certainly the form factor of this particular building is quite simple, but that doesn't hide the fact, well, it kind of does hide the fact, I guess. It doesn't take away from the fact that there are some design details that had to be figured out, particularly around the windows and the cladding, the constant concern, I guess, during the design and detailing phase that at any moment the board of the university could decide to not go down the passive house route, and having to maintain that flexibility of the cladding right up until when they got confirmation to go the whole way. And even just integrating the services, that's not an easy thing to do in any building, to figure out the ventilation requirements for 220 bedrooms. That's quite a big challenge.
Indeed. Yeah, no, it's true. That's true. Right. He makes it look easy, I guess.
Yeah. And the other thing that I'm glad he touched on was the cladding and making it look a bit more interesting than just a big long box, because there is a danger of having a repeated unit like that and a very simple form of making it not very aesthetically pleasing. And I like the way that they've approached that by adding some texture and some different shading and colours to the outside. I think that's clever architecture. And I enjoy seeing presentations that emphasise that at conferences, where they show the thermal envelope is a very simple form factor, but that doesn't always have to be directly translated to the external aesthetic and the look of the building. So someone can look at this and say, "Oh, that looks fairly intricate," but in actual fact, when you look at a plan view of the thermal envelope, it's pretty straight lines.
Yeah, I remember actually being kind of struck by that when he presented this project, because my first impression looking at the images wasn't, "Oh, it's a box." But then he pointed out that it was a box, and it's clearly a box. Yeah. No, so that's well done.
And I just think that's really clever design.
Yeah,
I like that.
Agreed. Absolutely.
And then, of course, there's the prefabrication element of this project, and I quite like that scale of prefabrication where you essentially set up a small plant on site and get the benefits of prefab without having to engage some remote party and then deal with transport and everything else. It's interesting what people come up with when they are forced under other constraints like they had, both coming out of COVID, but also needing to get this thing finished before the start of term. So they had a very hard deadline to reach.
Yeah, that was, I can imagine some stress involved there with that deadline. You don't want to leave a bunch of students homeless for the first year of college.
Not a good look.
No, I was really impressed also by his anecdote about the heat dome. I mean, again, this is probably because I lived through that heat dome, and it was completely ridiculous and horrible. And our house was nearly unlivable. It's not, to be clear, it's not a passive house. And so to hear that it sounded like it was almost accidental, the timing, but that the cooling system needed to be shut down, and so they kind of chilled the building, and then it was very resilient, only going up 2 degrees every day. I'd love to dive into that more and share that story. We have some really compelling stories about the passive resilience in very cold weather that come out of the experience of the deep freeze in Texas and Austin, and then there was a cool experiment that folks just did in Hudson Valley around that. But this heat dome piece would be really, I'm looking forward to learning more about that one.
Well, it's such a neat case study because, I mean, there's an image on the article that we've got on the Accelerator website of the building covered in snow, or snow all around it, and that climate there. You've got those extremes where you've got the really low winter temperatures, but you've also got really high summer temperatures. So it's not like in a West Australia house where you've got to optimize it really for keeping cool, or freezing cold house up in the snow somewhere on a ski field that you just optimize for winter. It's got to do both.
Right. Yeah. It's not one or the other, which he's also tackling in with the Vienna House, right? With Vancouver.
Yeah.
You mentioned that Vancouver has a kind of the toe in a cold climate, a toe in a hot climate a little bit because of the where things can go with the extremes. And when he just described it, it made sense, but I hadn't made the connection that with the title Vienna House and the typology of buildings in Vienna being, with the thinner shape around the courtyard. But it was really interesting to hear how they're tackling, not just dealing with with cold weather, but making sure that they're kind of investments and moves with the envelope that allow the building to deal with cold weather don't undermine the building's ability to withstand high temperatures as well. Yeah.
The Vienna House project looks very interesting. We'll have to get someone, maybe get Jamie back, or have another session on that.
Yeah, definitely.
Awesome. All right. Anything else?
I don't think so. No, it was great. A great interview. Thanks for sharing it.
Yeah, well, it was great to have that connection, and check out publicdesign.ca, and they've got some great images of the project and some of the other work they're working on. But also, if you just search Skeena on the Passive House Accelerator site, SKEENA, you'll find the Passive House Live that Jamie appeared on, but also there's an article there, and then you'll find this episode as well. So lots of great resources to check that out, and other similar work that Public's involved with. All right, what events we got coming up?
Well, we have a great week coming up. And so on Tuesday, May 31st, which is Wednesday, June 1st for you in New Zealand and Australia, we have a Passive House Accelerator Summit. So we're going to be doing a summit called Expanding Missing Middle Housing Solutions. And Timothy McDonald from Onion Flats is the moderator for this summit. And we'll have Bryn Davidson of Lane Fab, based in Vancouver, BC. Dylan Lamar of Cultivate Inc. He was with Greenhammer for a long time and now has his own firm focused on missing middle housing in Eugene, Oregon. Julie Klump from POA, who I believe is based in Massachusetts. I should check that, actually. I may have that wrong, but Julie's Julie's a portfolio of work is kind of massive, a bunch of affordable housing, really cool passive house work, and Liz Haver of Place Taylor in Boston. So anyway, great lineup of panelists, and we're really excited about the summit, and we hope folks will join us. So we'll include a link to, in show notes about that. And then the Passive House Accelerator Live will feature a project showcase edition, and this is called A Developer's Perspective. So this is focused on the work of AJ Patton, and he is with the Solar Chicago Fund and 548 Capital. He is doing two big multifamily passive house projects in Chicago. I think they're both 60 units. These are, I think, will be the largest passive house work in that city. He is going to be including in the conversation project or the architects on these two different buildings. So Leslie Roth of Lamar Johnson Collaborative and Doug Farr of Farr Associates. AJ will be talking about the projects as well as creating inclusive project teams. And I know all of us in the Passive House community will always eat up a presentation by a developer, because and this is going to be the case with this one. When this is for me, it's like validation. When developers are like dialing this in, figuring out how to make it all pencil, see how it will work financially, and recognize how the benefits of passive house will accrue to the people who live in these buildings, but also it's a smart business decision. So I'm really excited about this awesome. Showcase.
Awesome. Well, if you missed any of that, or if you want to find out and stay in touch with what's going on, then head over to the Passive House Accelerator website, and you can sign up to newsletter, and you'll get all of that and more in your inbox. All right. Well, thanks very much for listening into this episode. We'll be back again next week with another podcast. So until then, have a great week.
Thank you.